Okay, the inside of a large industrial container has a height of 3 meters, measured correct to the nearest 10 centimeters. It is used to hold a single stack of flat metal plates. Each metal plate has a thickness of 4 centimeters, measured correct to the nearest millimeter. Find the greatest possible number of these plates that could be stacked in the container. Okay, so in this case here, right, it's important to realize that this large container has a height of 3 meters to start with, okay, but it's measured correct to the nearest 10 centimeters. So there's an error sort of with this here in terms of this measurement, but also with the plates. Okay, they say the thickness of them is 4 centimeters, but again, you know, the measurement here is correct to the nearest millimeter. Okay, so find the greatest possible number of these plates that can be stacked in the container. Okay, so we want to work out how many of these we can fit in here. Okay, now of course what's really important is that we look at the upper boundary values and lower boundary values for each of these different things here. For the container, for instance, 3 meters. Okay, so the container is 3 meters. Now it does say to the nearest 10 centimeters, so perhaps what I'm going to do to make life easier for me, I'm going to call that 300 centimeters. Okay, because of course 100 centimeters is a meter. Okay, so 300 centimeters there. Because this measures the nearest 10 centimeters, the measuring stick, so to speak, that would measure this would be going up in tens. Okay, so this is the measuring stick that we're measuring this container, and they said it's 300 centimeters to the nearest 10. So the highest it could be, of course, on this measuring stick is here. Okay, the greatest it could be is 305, and the smallest it could be is here, 295. Okay, so the greatest would be 305 centimeters, the least 295 centimeters. Okay, now the plates, thickness of the plates, let's have a look at the plates. So with them it says 4 centimeters to the nearest millimeter. So even though they use a different unit here, I'd still keep it in centimeters because we've got these in centimeters. So 4 here, now to this nearest millimeter, in other words, it's going up in 0.1, so to speak. So 4.1 would be the next measurement, and 3.9 would be the next measurement. Okay, so that's the rule of this, measuring the thickness of these plates to the nearest millimeter. Of course, the greatest it could be then is going to be here, isn't it? So it'll be 4.05. Okay, and then the least it will be here, 3.95. Okay, now to work out the greatest possible number of these plates that can be stacked in the container, alright, think about it. We want the greatest amount of plates that we can shove into this container. Have a think about what container we'd need to start with. Okay, what would be best to start with? If you wanted to be really optimistic here now, you wanted to get as many plates in as possible, what type of container would you want? Would you want the container that has got the greatest measurement or the least measurement? Okay, and of course if you think about it logically, we're better off starting with the greatest possible container. Okay, so the greatest possible container is 305. Okay, and then if you think how many plates we could get into that, okay, well, to maximise the amount of plates, of course, if we'd have the smaller plates, we get more in, wouldn't we? So to work out here, what I need to do is I need to do the greatest divide by the least. Okay, greatest divide by the least, that will give me the greatest possible number. So in that case, the greatest would be 305 divided by the least, which is 3.95. Okay, so I better go and grab a calculator. And here I am. So we've got 305 divided by 3.95 77.2. Okay, so it's the greatest amount of plates you could actually get in there. Now, of course, you can't get 77.2. Okay, plate. Oops, we get 77, didn't we? Okay, 77 plates. Is it always possible to stack 73 of these plates in the container? Well, is it always possible? So it might not be possible. We have to see. I mean, if we think about the biggest plates, yeah, let's go for the biggest plates in this case. Can we get the thickest plates, 73 of them in here? If we did 73 times the greatest, okay, you get out 295.65 centimeters of height. Now, if you go back up here and look at reason up here and think, well, it might not actually be able to do it, because the least container could be of that height, and if you have the greatest plates, it could give you this height, so it wouldn't quite fit in the least container. So you could say that no, it's not always possible. Not always possible. Okay, the greatest thickness plates will not fit into smallest container. Okay, so some sort of statements like that, and we've proven it. We've proven that it's not always possible.